So hello students, in the last lecture we have discussed about the internal energy and the concept related to that, and we have discussed that how we can calculate the internal energy in terms of degree of freedom. So I hope you are fine and you are fine with it, and today we will be going to discuss heat. So today, continuing on the thermodynamics lecture, we will be going to discuss heat. Though heat is already discussed in the thermal properties of matter, so but still I want to make you revise the concept related to heat. So heat is basically the way of exchange of energy between system and surrounding. The heat can also be the transfer of energy from one system to another when they are at different temperature. So the notion of heat lies in the fact that there should be a temperature gradient due to which there is a energy transfer, and this energy transfer we are calling it as heat. So the important thing about heat is that you have to feel it, because it is the internal energy of the system. So you cannot see it. So heat you cannot see that, the transfer of heat you cannot see. It is only what is you cannot see by the naked eyes. So heat is just the way you can feel it when some body is at higher temperature. Then if you touch a hot object, then you feel it that your hand is there is a transfer of heat, and due to this there you will feel hot. So that hotness is due to that energy stored inside that body, because that is at higher temperature and that is hot in nature. So heat is the concept of heat is that you only feel it. Okay. So so there are different ways in which heat is transferred. So that is conduction, convection, and radiation. So in case of conduction, it is the vibration of the molecules. So suppose if it is a solid body, so there are at microscopic level these molecules are arranged, or some molecules are like this, and some temperature gradient is there such that T1 is greater than T2, and due to this there is a movement of between these two particles, and there is due to this vibration the energy transferred from this to this, this to this, this to this, and so on. So that is what we call as conduction. In case of convection, there is a actual movement of molecules. So that is, if you see in case of boiling, so that is the case of convection. In case of radiation, so radiation is because of when we have when we have a hot body, and it radiate heat. So it radiates heat based on the property of the based on the wavelength of the radiation that is emitting from the hot body. So these are the different kind of processes through which you will see there is a transfer of heat, and the main important point that you shouldn't be forgot is that temperature differences should be there. So in the last class we discussed about internal energy, and in today's class we will be going to discuss what we called as, well, let us say Q, that is heat, and in the upcoming lecture we will be going to discuss work. After so we have already discussed this, we are currently discussing this, and in future we will be going to discuss work. Once we are clear with all of these concepts, we are fully acquainted to go on to the first law of thermodynamics. Okay. So basically when the concept of heat arises, so there should be a definite concept of, in case of solid bodies or in case in any fluids also, so that is the case of specific heat. So specific heat capacities is, so in thermodynamics we should be going to discuss what is specific heat capacities of a gas and what is the range of specific heat capacities. Okay. So I am telling you the range of specific heat capacities of an ideal gas. Gases varied from 0 to infinity. So in this discussion we are constrained ourselves for the case of ideal gas. So specific heat is, if we know, so how specific heat is defined, if this is C, so we have discussed that Q divided by m into delta T. So what specific heat is? So the heat required to raise the temperature of 1 gram of gas by 1 degree centigrade. So that is what we called as specific heat. So the two processes that needs to be discussed is, that is, we know that is isothermal process. So in isothermal processes, the process in which there is no change in temperature, that means delta T is equals to 0, and so for the case of isothermal process the C is infinity. So if you see, if you put delta T to be 0 in this equation, so that is C is infinity. So in case of adiabatic process, so the adiabatic process is that in which there is no exchange of heat, so delta Q is 0. So C for the case of adiabatic processes, delta Q by m Cp mc delta Q by m into delta T, and we know delta Q is 0, so C is 0. So from these two processes we can see that the range of the specific heat is going from 0 to infinity. So the range of C belongs to 0 to infinity. So now that is all about a specific, the concept related to a specific heat. So this concept is important to understand. So we are able to relate the different specific heat with the internal energy. So for now we are restricting ourselves that how specific heat is related to internal energy. Okay. So in case of, so there are other thermodynamic processes. So that is isochoric or isobaric. So these are important because these the specific heat in case of isochoric and isobaric will tell us that how we can relate it to the different forms of energy. So in case of isochoric process, so delta V is 0, and in case of isobaric process delta P is 0. So when delta V is 0, so that is for the case of constant volume, and when delta P is 0, so that is for the case of constant pressure. So it means to say that so there is a transfer of heat in case of isochoric process. The transfer of heat is at constant volume, and so the C we called it as, that is, so because it is isochoric, so we can call it as CV with subscript V, and so that is delta Q by m into delta T. So I think I just should check. So okay. So in case of isobaric process, so the transfer of heat is at constant pressure, which means that we are calling this to be Cp, and that is delta Q by m delta T. So in order to understand the concept of Cv and Cp, we need to feel it. So how can we feel it? Like suppose we have a body, and so in case of isochoric process, so there is a transfer of, so we have some gas molecules, let us say, inside this box, but the volume is is fixed, but there should be some temperature gradient due to which there is some transfer of heat. So there is T, some T here and some T here, and let's say some, or we can say that some energy is supplied to this body uniformly in order to increase the temperature of this gas molecule inside this box by 1 degree centigrade. And in order to do that, so the temperature is increasing, but we have to consider that the volume of this box is constant. So volume is not changing. So that is for the case of isochoric process. So similarly, that is true for case of isobaric process. So in isobaric process, if we want to keep the pressure constant, then it is obvious that we need to change the volume of the system. So this cannot be done with this fixed set of volume. This can be done, suppose we are having a piston and some gas molecules are inside this, and you apply some heat source here. So you want to change the temperature of this gas molecules by 1 degree centigrade, but now what you want is the pressure, so because this is the isobaric process, so what you want is that the pressure should be constant. So in order to keep the pressure of this gas constant, so there is an obvious possibility that there should be some expansion. So the details of all these expansion and all other things will come later, but for now, to get a feel that how the things are happening, so we need to understand this process, and in this process the specific heat that we are defining is Cv and Cp. So let's forget about this for now, but if the energy that is changing this, the energy of the molecules that is required to increase the temperature at constant volume is called Cv, and that is, we can say that this is nothing but dq by dt at constant volume. Okay. So this should be, you should be keep aware of it. So this is du. So now what I am relating is, so this is nothing but internal energy. Okay. So different processes we have discussed. So in case of adiabatic process, in case of, so we have having different cases, isochoric, baric and isothermal. So in case of adiabatic process, the specific heat so in case of adiabatic process, we know delta Q is 0, which implies that C in case of adiabatic process is 0. So the maximum, or sorry, so in case, so it is always the case that in case of adiabatic process the C is 0. In case of isochoric process it should be something, and that is delta Q by m into delta T, that is also delta Q by m into delta T, but we should be aware that there is constant volume in this case and we have constant pressure in this case, and in the case of isothermal we have temperature should be, delta T should be 0, and this is going to be infinite. So this you need to keep in your mind and we'll proceed from here and we'll try to relate the specific heat with the degree of freedom in the next class. Okay, so I hope this is clear. So we'll meet in the next class. Thank you.